The title of my presentation is The Dilemma Between Industry 4 and Society 5, a technological evolution of digital transformation or a humanitarian revolution of well-being. First of all, it is critical to set the theoretical background of this topic. Social cohesion and the humanity prosperity are issues directly linked both to the evolution of traditional humanitarian ethics and to the rethinking of indigenous cultural morals. Society 5 and Industry 5 can be reviewed in terms of improving humanitarian values and ensuring sustainable development at an Industry 4 following up. It is not a direct transformation since sustainability and the coexistence of humans and machines turns to be a debate between Industry 5 versus Industry 4 or the critical issues of shifting between Industry 4 towards Society 5. Another set of theoretical assets that we have taken into account is that within the last decades of analysis, academicians, industrialists, and researchers are more concerned about Industry 4 as it is on the verge to get obsolescent, which led to the development of Industry 5 as a necessity. However, there are currently modernist and social scientists who have discussed the fifth revolution concept and its applications in various fields such as manufacturing, healthcare systems, and hospitality. The idea of Industry 5 is entirely based on a human robot co working and bioeconomy based on intelligent manufacturing systems and digital technologies. The critical point remains the convergence between theory and in-field application of Industry 5 in the wider terms fields of benefits, limitations, synergies, symbiosis issues among the fourth conceptualization with five conceptualization. Let me here present to you a paradigm of Industry 5 evolving into Construction 5. Industry 4 represents the vision for the integration of information, objects, and people in cyber-physical scenarios in order to transform factories into intelligent environments. Although this transition is still ongoing, the corresponding vision of Industry 5 has already emerged. Therefore, Industry 5 aims to bring the human factor back into the production system with the collaborative work paradigm of human-robot collaborations at its core. It is therefore critical to answer how Industry 4 has conceptually evolved and is being implemented in several critical sectors of our modern economies, like the construction sector. This is an approach that has been literature reviewed and bibliometrically analyzed, and researchers assessed the Industry 5 momentum as a literature trend, drawing on bibliometric comparisons between the Industrial 4 and the Construction 4 vision. Therefore, Construction 5 is proven a novel bibliometric analysis comparing data from literature Industry 4, Construction 4, and Industry 5. Saying this, I would like to stress out that it is critical to firstly define which is the field of Industry 4, Industry 5, Construction 4, Construction 5, or other conceptualizations from which we have to make the comparison between them and to find common ground of collaboration or a possible opposition of parameters. Another paradigm of Industry 5 evolving is considered according to the convergence of the Sustainable Development Goals of increasing individualized demand products, resilient manufacturing, under the envisioned Industry 5 proposition. In this proposition, there are concerns are raised regarding the conventional centralized production control methods that suffer from low stability and inefficiency of decisions under frequent disruptions. Therefore, the establishment of an approach architecture named blockchain smart contract pyramid driven multi-agent autonomous process control targets at achieving the timeliness and the adaptability of control towards resilient individualized manufacturing. This conceptualization is designed in alignment with an agent encapsulation of manufacturing units. In general, blockchain smart contracts can be used as enablers of multi-agent systems for peer-to-peer negotiation and coordination of tasks. Another characteristic of blockchain smart contracts is to enable the multi-agent system for peer-to-peer negotiation and coordination tasks in similar sustainable development goals as they have been set and issued nationally or globally. Another conceptualization and the field of application of Industry 5 is the concept of environmental, social and governance with the acronym ESG. Industry 5 offers a powerful framework for understanding the role of technologies in enhancing the disclosure of ESG. This concept is increasingly used to evaluate the performance of firms and pension funds, guide investment decision making, and inform customer purchasing. The research on this conceptualization is still evolving, even though there are already sparsely published studies investigating the role of individual technologies, such as the blockchain's technology in ESG. However, there is a room for and space from a broader set of emerging technologies to improve the ESG disclosure and address the limitations that have yet to be explored and to be confronted, to be resolved. Another critical issue of one of industry of 5 concept is the managerial overview. Since the ESG relies on theories and views, including stakeholder theory, legitimacy theory, transaction cost economics theory, institutional theory, signaling theory, network economics theory, and the decoupling view. Therefore, it is critical to explore the application and the common ground of Industry 5 in order to enhance the ESG disclosure from retrospective to prospective in the real-time reporting, customizing ESG reports, extending the scope of reporting to multi-tier supply chains, reducing the costs involved, and enhancing the overall efficacy of this ESG disclosure. Of course, there are several governance aspects, challenges, and risks involved during the employment and the conversion and the implementation of Industry 5 to ESG. In these slides, I will collectively present to you some critical discussions, concerns, and future research orientations. First of all, we have to take into consideration the innovative approaches that have been based on concepts of I5. These approaches and concepts are presented in a holistic way from the point of view of production models, processes, sub-processes, and activities. Likewise, there are benefits and the challenges of these novel approaches, like that of Pro S5 and Construction 5. Of course, there is only indicative mentioning, but there are also many other positive prospects that can be further developed, considering the practical implications and directions for future research on this topic. Besides to future research projects, there is also a concrete set of recommendations for university and academia environments aiming at developing new forms and channels of distribution of education, research and innovation with the context of new cooperative models that can help the achievement of sustainable priorities. Such a paradigm is the quintuple helix model and the Society 5, which can be characterized as a socially and digitally engaged model. Another critical aspect that we can take into consideration is that according to the framework of Industry 5, niche technologies as that of a smart factory should combine digitalization and prediction activities with a greater sustainability and human centrality within working processes. Therefore, optimization and improvement of manufacturing processes have to meet cost criteria related to energy consumption, safety, and implementation of new technologies. Someone cannot undermine the possibility to demonstrate automatically generated and to visualize multiple layout solutions of collaborative workplaces, followed by the simulation of the interaction between human and robots, considering that the most significant tasks during the designing process are human-robot collaboration workplaces layout. Therefore, this workplace can be designed according to an optimization criterion by using the full integration of a numerical computing platform with an interactive 3D visualization environment. Then, regarding the variations of the input parameters, the visualization of new layout solution can be reasonable and realistic in a fast and effective way. Finally, we can mention that regarding the human-centric pillar of Industry 5, there have been proposed methodologies to address the need of a human artificial intelligent collaborative process design and innovation approach to support the development and deployment of advanced collaboration tools. In the context of Industry 5, collaboration architecture can provide a new adaptable generic framework, concept or methodologies for modern knowledge creation in order to share and to enhance planned collaboration processes. This architecture can also provide a truly integrated human AI collaboration model equipped with methods and tools for human AI-driven co-creation schemes. It is a framework that can be co-execute processes and activities with humans remaining a powder in a control. Therefore, this framework can be also focused, prioritized on the human AI collaboration processes and activities in industrial plants, having also potential applications to other societal contexts. Here I present to you some indicative citations and published studies related to these presentations. I would like to thank you very much for your attention.